So yesterday, I recorded yesterday's lectures. One of them didn't have sound, which was kind of unfortunate. And I put them out here on the website. So those people who are brand new to ITU and don't know about the process, the recorded lectures are from my computer, and they're being uploaded here. So these are the 4 from yesterday. Number 3, unfortunately, didn't have sound for some strange reason. I haven't really figured out why. But it could be that I just recently upgraded my operating system, so probably a little glitch I didn't discover. The other thing that I put up here is the solution. Remember yesterday we were talking about assignment number 2, or in-class assignment number 2, the dependency diagrams. And I said, I'll post a solution. Well, I did, but it's password protected. So you can't look at it yet. So Tuesday is the deadline for yesterday's work. So on Wednesday morning, I'll either replace this one or I'll give you the password. I think I'll just send the password out by an announcement so that you can take a look at the password. And on Wednesday, your assignments may actually be graded too, sometime Wednesday night. So you'll know exactly how you did on them. So we're trying not to do all of the grading on the last week of class, which is kind of nerve-wracking because then you've turned stuff in all term and you don't know what you're going to pass or fail or what until the last week of class. So we'll be able to track it and just keep it current as we go through. So after this weekend, you'll know whether you're passing the class at this point. So which is great because then it's encouragement to continue coming, for the next weekend. Those people who haven't shown for 1 or 2 days of this weekend aren't going to pass it. So then they'll know immediately as well, which is also probably a good thing to know about instead of waiting till the end of the term. So anyway, I put this solution here. If you click on it and you open it up, it should ask you for a password. Let me just checking it right now. Yep, there we go. It's password protected. So I'll send the password out as soon as the expiration hits on the upload. So after Tuesday night, you cannot upload this anymore. It's done, especially after I give the password out. And just because I'm not going to see you after this weekend, until the next weekend, I know that the solution is like one way of doing it. And as you've discovered probably with your dependency diagrams, there's multiple different ways of thinking about it, putting it together. And so there's no right or wrong answer to it. There's different variations of the same theme that are showing the same information. So don't be panicking if your diagrams don't look like the solution. And most likely on the final exam you'll have to write either a dependency or an entity relationship diagram given a problem scenario. So it's good practice, actually, kind of just to compare what you wrote with what the solution looks like. Then you might learn a little bit more techniques in terms of thinking about it and analyzing it. We have another exercise here that's marked for day 2. It's going to be an in-class exercise for which there is an assignment for, which I'm going to go through next after I go through the second part of the boring lecture stuff. I call it boring lecture stuff, but it probably is not too bad. So this lecture is 4B, and it is the continuation of the entity relationship stuff that I talked about yesterday. So we're going to finish entity relationship diagramming, and we're going to start in with an exercise, then we're going to have lunch, and then this afternoon it'll be about SQL, which would be kind of cool, actually a little bit different. So same kind of pattern as yesterday. So we'll probably do an hour-and-a-half lunch, and we'll probably leave at about 5:30-ish. So, because we're not taking too many breaks, we're going straight through. It's really hard to take a break in this class because everyone's got to get up. And just it took us 20 minutes just to get you in a seat. So imagine what's going to happen if we took a break every 10 minutes or every hour. It'd take 20 minutes just to get you back into your seats. So this just doesn't work out that well. So we'll just go straight through. Just like yesterday, if you have to go to the bathroom, your phone rings, you're hungry, I don't know, something happens, feel free. It's not rude. You don't have to sit here and suffer. You can actually get up, go to the bathroom, come back. It's not rude at all. So some students think it's rude, kind of. I don't know. Especially it's really hard if you're sitting up front here because everyone's going to see you leave. But and then also another thing, I'm going to put a table in here at the lunch break. 2 tables actually, because we could actually fit you into a table so you don't have to rest your notebook on your lap. So try to accommodate. We could, but the only problem is there's a terrible echo. I did request for them to increase the air conditioning. So, hey TA, Could you remind them that we need to lower the air, we need to turn the aircon on? Yeah, tell them at the front desk. They haven't done it yet. Usually I hear it click on. They need to turn it on. Because otherwise it gets kind of muggy in this room. So, it's all the people. So. All right, now that we're past people issues, let's talk about entity relationship diagramming. So mapping. So we know how to hopefully how to create some of these, and so we're going to look at how to map it now, which is why this is a good technique for designing databases. So in terms of designing the tables, this is a review of what we did yesterday. We either draw a dependency diagram or we draw an entity relationship diagram. In the old days, they called them dependencies. And you can kind of see where there's a little bit of difference in terms of the symbols. Oh, now I heard it click on. Perfect, thank you. It just clicked on. Yeah, no, I heard it click on. I just hadn't heard it clicked on before. Thank you. Alright, so we draw the dependency diagram or the entity relationship diagram. And then each statement is a single path through the diagram, as we saw before. And then the tables are formed by traversing the dependency diagram. And so we're going to use this same concept with an entity relationship diagram, because the entity relationship diagram shows us a little bit more. It shows us the relationships, not just the dependencies. So we can create an ER diagram using the dependencies, transform entities into tables, transform the relationships into keys, and then we're done. And then no paths to follow. So we're not going to actually try and follow paths through, because one of the things that you should have gotten out of the dependency exercise that we did yesterday was the fact that there were multiple ways of doing it, and depending upon how many paths you're putting in the diagram, you're going to get different results in terms of the outcome that's going to turn into the tables. So instead of using that approach, we're going to use a different approach that doesn't follow any paths and doesn't rely upon the dependencies. So this is the starting diagram, and it looks kind of complicated. It's kind of color coded for a particular reason. Hopefully you can see this. I'm not going to start building this. We'll save you the work. We'll just start with the finished diagram. And here's your finished diagram. We have employees that work for departments, and employees that manage departments, and employees that work on projects. And the projects are departments control the projects. And employees are dependents. They have dependents of dependents of employees for the health insurance policy. And then we have a recursive. This looks like a recursive relationship here, where we have an employee that's a supervisor, and there's a supervision relationship between the employee and the employees. And this notation is more along the lines of what I like to do with the n's and the ones and the asterisks for cardinality. One of your assignments is going to have you put in cardinality, and we talked about cardinality, and we also talked about participation yesterday. This is just showing cardinality. The second number is always the one that's going to be shown. The first one is the participation number. So if we went 1 dot dot n, or we went 1:1 or something, we have two numbers. So this is the second number if there's only one number. N meaning any number, 1 meaning exactly 1, so, or 1 dependent. So here we have a combination. Ignore the double lines here. I'm not quite sure how they ended up being doubled. So they don't mean anything. They're just darker. In fact, I think what I tried to do is, because there were so many lines, and these lines here to the attributes are single, and these lines here are supposed to be double, but I forgot to do this one here. So this would be a weak entity example, because it's not a strong entity because it relies upon another entity in order to exist in the system. So now I feel the air. It's nice. I think because the air is coming out of here somewhere. All right. So now we can. First step we're going to do. So we're gonna start translating it, and then after I get done with this PowerPoint lecture, then we're gonna do it for real, or not for real, but I'll do it. I'll attempt to do it, and I'll show you. I'll put up the I'll show you where to find it as well, and we'll go through a little exercise of translating it. So in this particular case here, we're going to first review the key constraints. So here we can look at and go, well, an employee. What do we mean by key constraints? These are the business rules, or the things that we're going to enforce in our diagram. So we have an employee that can work in many different departments, and then a department that can have many employees. And in contrast, each department has at most one manager. And then according to the key constraint on managers, this is the case that there's only one manager, because we can look at here and go, okay, managers, there's only one manager per department, 1-to-1 kind of thing. So after we verify, what we're doing is either putting it into the diagram or verifying it, just as an iterative practice, just reviewing it to make sure you've got it correct, because the entire diagram translation relies upon the cardinality. So if we don't get the cardinality right when we translate those diagrams, there's an extra chair up here. There's an extra chair way up here. So then we also review the participation constraints, and in that, does every employee work in a department, which is one of our questions, and if so, this is a participation constraint. Basically, it means that at least one employee works. So we're reviewing the multiplicity, we're reviewing the participation, we're trying to make sure that the diagram is accurately portrayed. And then we look at and identify weak entities. Usually people will leave weak entities out of the diagram. They'll go, well, what about those dependencies? Well, are they really in there? You know, those dependents that are going to be on the health insurance policy, are they really part of the company? No, because they usually get left out. So putting them in is usually a kind of a secondary thought. So a weak entity can be identified uniquely only by considering the primary key of the owner entity. So we look at the owner entity and we go, well, employees, there's a policy, and then there's dependents. There's dependents that are on this policy, and there's a cost that's associated with the policy, and there's a name and an age of the dependent that we need to keep track of. And then the owner entity sets, the weak entity set must participate in a one-to-many relationship set, or a one owner to many different weak entities. Otherwise, you wouldn't actually have it out as an entity, you'd use a field instead. So if you were only allowed to have one dependent, you wouldn't have a separate table for this or separate entity for this. You just have, like, you know, a spot in your personnel file that said, okay, dependent, name, and then you'd have an easier time. So then we have the weak entity sets that have a total participation in this identifying relationship set. So the total participation would mean it would have to be in there. Optional participation would mean that you don't have to have employees, you don't have to have dependents to be an employee. So weak entities have only a partial key, so it's usually a dashed line over here, which would be a partial key instead of a solid key. And then we review the relationships, make sure the diagram is correct, and all these steps in the beginning is just verifying your design, and these are kind of ways that you can do without translating it to see if you have the correct design. So if each policy is owned by just one employee, we can have this up here, which is really kind of a bad design in nature. This is a better design because we're putting in a purchaser, a beneficiary for the policy, and we have a policy ID and a cost that's associated with the policy. And so the key constraints on policies would mean policy can only cover one dependent up here. So this is a better design so we can cover more than one dependent in terms of the concept. So after we've revised the diagrams and reviewed them, then we also can take a look at the relationships themselves. And previous illustration illustrates a case in which there's two binary relationships where better than one ternary relationship, and this is a ternary because we have three participating entities in here, so we created two binaries instead, which may or may not give us the correct number of tables depending upon our logic, but we made it easier for us to understand the diagram. And so as another example, in the other direction, the ternary relationship, the contracts relates to entity sets, parts, and departments and suppliers, and so a descriptive attribute quantity. So there's no combination of the binary relationships with an adequate substitution for that, which means when we put this all together, we can take in consideration the three parties that are participating in the relationship. Here there's nothing that we can do to connect the three of them together if we separate them out into two. So what you're going to end up doing is drawing diagrams for problems. Well, we're going to go through one actually. And then you're going to go, well, isn't that like two relationships? And you'll have a bunch of relationships, you know, and you'll separate them all out. And it's easier to understand it that way. Unfortunately, though, it's harder to translate that into diagrams because you're going to see in a few minutes how we're going to translate them, and then you're going to go, well, then we have a little overlap. Because we have more relationships that way, and then the more relationships we have to start eliminating the unnecessary ones in terms of the concept. So in terms of the reviewing the relationship, we have this guy over here versus this guy over here, and they both look the same. This is why your dependency diagrams, some people have a tendency to do this, and some people have a tendency to do this. It depends on your style of diagramming, which is why when you start looking at the dependency solution, and you look at your solution, and the dependency solution is going to be more like this, and you may have done this, or something. So, and they're really saying the same thing, as long as they're enforcing the rules correctly. And here we have S that can supply P, and D that needs P, and D that deals with S, but it doesn't imply that D has agreed to buy P's parts from S. This might actually not say the agreement exists either, although there's a contract that's tying them all together. Here the contract is not necessarily represented. It just says that it's going to deal with it. So the business rules, there might be some business rules that are missing, is the point that's trying to make, depending upon your style of diagramming. So now that you're familiar with the diagram, these are the things that we're looking at in terms of the relationships between the entities. First thing we're going to do, so if you're making notes, this is where you're going to start writing stuff down or start thinking about it. This is how we're going to translate. So we have the complete diagram set, and it's usually one diagram, hopefully. It could be, you could do this with multiple diagrams for the same system that you're building. Step number one, each one of the entities turns into a table. So I have 1, 2, 3, 4. So one of them here, and I'm going to skip ahead because I do it in both sets. You're supposed to take all the strong entities, put them in the tables, and then take the weak ones after you've analyzed the table data. But I'm going to say just up front, weak and strong entities, they all turn into tables. So we have another one we're going to add later. But so employee, department, and project. So we give the table name generally something that's associated, so we can trace back to the diagram, something that we've used in the diagram. So in the diagram we call them employee, department, project. So that's really going to probably be the table name. And then when we traverse it, we have to go look at the connections between the. So we have employee and we have a department, which means the employee has to be able to be uniquely identified by the department. The department needs to uniquely identify the employees. So at the first step, we identify the primary keys that are going to be associated with each entity, because we're not going to include any of this other stuff. We're just going to pick something here out of employee, probably going to be social security number or something, and then out of here in department, probably going to be a number, department number. So we have employee social security number, department number, and then we can have a project number. Over here on the project, we have a project number. So you may also notice it's kind of hard to see it, but there's some underlines going on in this diagram. So the underlining is supposed to be, and it's a little inconsistent actually. If you're doing the diagram this way, you would underline the primary keys so that when you built the table in the first step, you'd know which key was intended by the diagram to actually turn into the key for the table. So it makes it a little bit easier to translate it. Also, when you have multiples, in fact this particular name, the department has a number and a name, and they're both underlined, which means we haven't actually picked them as primary keys. We just know that these are going to be candidates. So this is where the candidate concept comes into place. Some people like to underline stuff, some people don't like to underline stuff, but when you're drawing the diagram, you can easily identify that's going to be unique. Departments are going to have different names. What if we have shipment department though? We have shipment in customer service, and we have shipment in another one. Might be reusing the name, so the department number is probably going to be the more reliable kind of name associated with the department, but who knows. Okay, so after we get done with all of the entities, take the weak ones and the strong ones, turn them into tables, list out the primary key. Second thing we're going to do is we're going to take a look at the relationships. So the 1 to any number, the n relationships, create the primary key. So for the 1 to n relationship, you create the primary key from the entity on the one side to the entity on the n side, or any number side, where it will become a foreign key. So we have the primary keys just by sight or just by knowledge of the data and the elements of the data on the one side. We get the n side, so we know we have the foreign key, because the table that we have a relationship with is going to be the foreign key. So our primary key in one table is going to be our foreign key in the next table. So we know which ones we're going to use by which ones we've identified. So employee N over here works for department 1, so department number is going to be moved to the employee table, and in the employee table the department number is going to be the foreign key. So actually it seems it's very simple, hopefully. I mean, it should seem kind of straightforward. So if not, stop me as we go through this. And if you follow this guideline, if you follow those rules, you'll develop perfect third normal form tables every time. Repeat this one again? Okay, so in here, if we follow the 1 to n's, so here we have this employee and department has a 1 to an n. This is why when we're reading the diagram, we have to look at these numbers up here. The 1 part, department part, is going to give us a 1, which is going to give us a foreign key for this table over here. So we can put all the 1's, I mean there's only 1. So which means we can create a field in the other table that's going to represent the linkage between employee and department by telling the employee that we have a department number that he works in. The rule is going to be different if this is more than 1. If this is an asterisk or if this is a many side. Many's form different tables, but I'm going to get into that in a second. But if it's a 1, it's a number, any number of employees, and they only work in one department, then that doesn't turn into a separate table. It turns into a foreign key, and the foreign key ends up being put into the employee table. So, which is, interesting that the logic works that way, but it does. So we have, and we already identified the foreign key, so we know that we're going to put department number into the employee table. So we're going to have that as a separate. So we add. So what a lot of people will do is actually just open up a piece of paper, and they start listing out the tables, and they start building it. The first one is going to be the foreign. The first one is going to be the primary, and then the second entry is going to be the foreigns. So each one of the tables that has that type of relationship is going to get another key in it. So you're going to have the primary, then you're going to have the foreigns next to it. And that's how, when you start looking at the documentation, sometimes you see all the keys up front. You can tell if they've not done it this way when you see them mixed in. And you go, oh, that was an afterthought. Oh, that was an afterthought. Oh, that was an afterthought. Instead of just methodically just working through the primaries to the foreigns and then to the data, to the column attributes. So it doesn't really matter. There's no right or wrong, though, to it. It's just different styles of creating the tables. So after we've done that, so the department number is now moved to the employee. I'm going to show you the finished result here at the end, and we're going to go through this entire exercise as well. So we'll have some practice with this. And this is what you'll be doing in a couple of your assignments, actually, for the course. So the department number is moved to the employee entity. And then we examine the weak entities. Well, we're doing the same thing with the weak entities as we've done with the strong entities. We're just creating tables out of them. So the dependent entity cannot exist on its own, and so it must have a parent entity, the employee. But we're going to make a composite key out of it. So we're going to add a slightly different style key to the dependent table so we can tell which employee the dependents belong to, rather than having, because we're going to have more than one dependent per employee sometimes. So they are identified by a many to n relationship as an intercept entity, with a primary key that's going to be a composite of the primary key of the 2 or more other strong entities. So this particular weak entity only has a relationship with one strong entity. So here's how the key works. So the primary key is going to be the employee social security number, because that's the primary key that's associated with the employee entity, plus the dependent number. And the dependent, when we identify that entity, we pick the primary key, we call it the dependent number. Good practice to use the same wording. Because we know if we start changing it and call it social security number employee social security number, oh, they're the same thing, they're representing the same concept, but they're with 2 different attribute names. It's hard to keep track of them. If you use the same names, then in this table, the employee social security number is the same as over here in this table, employee social security number. So for each weak entity, you create a table. You include the primary key of the owner's table, so that's the employee. So the primary key becomes the owner key plus the weak entity key. So here we have the entity, the table, which the entity is dependent, the table name is going to be dependent, and the primary key is a composite key. If we just made the primary key dependent number, which people still do, and they don't consider it a weak, and they don't do a composite with the employee, That's how you can get rid of an employee in the system and still have dependents on the health insurance policy because there's no linkage between those dependents and all of the employees. So when you get rid of the employee, you should be able to also get rid of the dependents. How do you know all those dependents, which one of them belong to that employee? It's a composite. So you pull the employee you query on that social security number of the employee plus the dependent number, and then you've got the linkage, and then you delete all the dependents out of the health insurance policy. You could do that with cable service and apartment numbers as well. If you were keeping track of which people were in which locations that were getting service, then you could take the location out as well instead of just the people, which is kind of interesting. So, causes business errors if you don't do a composite, long story short. So what about the many to N or M to M's relationships? They turn into tables. So some relationships, like this relationship, doesn't turn into tables. That one doesn't turn into a table too. It's only this one here, employees that work on projects, that's going to turn into a table because we have a number to a number. And so we have the M to N relationship creating a new table with the primary key being the primary key of both entities involved in the relationship. So we have the employee table who works on projects. So we can actually call this table works on or I don't know, works for, whatever it is we want to label it. In here we have a composite of both. So the relationship, in fact this relationship table is a composite of two primary keys from two separate keys, which are going to be foreign keys actually. We could put a primary key in here, but we don't actually have to. So normally people go, well, tables, don't they always have primary keys? Not if they're relationship tables. They don't have to have a primary key. It can consist of all foreign keys with data. Because that's really what they are. So, which is interesting because people put primary keys on those tables. As an example, when you register for classes, you have a student number, student ID, and you have a class ID. Why do we need to know which registration number you are? Well, probably because there's other business rules and we want to be able to look you up by registration number. But what is the registration number really going to be? It's going to be a primary key that's going to be added to a registration relationship table that's going to be created. So usually that number is not used very much outside of reporting. How many students did we have register? Well, then we can say, well, what number, how high is the registration number? And we go, no, it's 99. Okay, so we have 99 students who registered. So they use it for, not really for querying, but for other business rules. So there's no law that says you can't put a primary key in this table. But if you're going to put it in, you're going to put it in for business rules. You're going to put it in for accounting or something. Not for linkage. So these are two foreign keys, one from the employee table and one from the project number. So employee number 1 with project number 1 has worked 3 hours, and this is the hours worked. And the hours worked is an attribute that was taken from the relationship. So normally with the many-to-manys, we can put attributes on the relationships. On the one-to-many or the many-to-ones, there's really no attribute because that doesn't turn into a table anyway. So people start putting attributes all over the place. And they put attributes on the relationships that aren't multiple. And then that confuses the person who's trying to translate it because they look at, what are these attributes for? Usually if you're doing that, the attributes are misplaced. They belong somewhere else. So you don't put attributes on relationships that aren't multiples. If it's a single valued relationship, there's no need for an attribute on that relationship. This project number of hours worked would be an attribute that would be appropriate for a multiple relationship, because now we have employee number 1 is also working on project number 2, 4 hours. So this is going to give us our linkage to put things together. So here's an example of a set of entity relationships. This is a one entity relationship diagram that is, we put the diamond in here because we want to see the relationship clearly versus if we just put a line in here, it's really hard to see it sometimes. And we put the crow's feet in here instead of all the numbers. This is a separate documentation style. So we have a product, we have an order, and the order there's a request for products on it. So each one of the orders, this is the crow's feet stand for many. So this is a many, this is a many. the dash here is a 1 or 0 participation, which means, well, the order has to have, well, actually the orders can exist in the system without the products because the products might be back ordered, or you might be able to create an order and not have it complete with all of the products. It may not contain all of the products in the system, which means there might be none products or there might be a lot of products in the order, but essentially you could have an order. Maybe it's a back order, a forward order, or something. This means that you have to have the products that are going to go on the order. There has to be at least one product that's going to be on the order. Otherwise, there's no products on the order. So the logic's kind of wishy-washy, so don't really worry. In fact, a lot of people would leave out the zeros and the ones, the lines on here, and just leave it open. And just put the crow's feet on here, which makes it a little bit easier to understand. Because after a while, it just sort of read like Greek. So you can see they have the order number underlined here. This one, this relationship has an attribute, quantity ordered. And on the product, we have the product ID over here. And then we have other attributes, that might be included. So if I were to translate this, in step number 1, I'd create a table for order, create a table for product. So I have order and product. And then step number 2, I'd take a look at, well, we don't have any weak dependent, we don't have any weak entities, so don't have to worry about that. And I take a look at the relationships, and we only have one relationship. So we call the relationship here order line. So is it really an order line? I could have probably called it purchase orders. Whatever you call the relationships are going to be up to you. There's no set. And then you don't have to call this order or product either. But if you do call it or label it by what it's in the diagram, it makes it easier to translate and go backwards to the diagram to see what the logic is supposed to be about. And then we can see here on the order number, just populated it in with, order date, promise date. And then over here, this is the relationship table where we've got the product ID and the quantity ordered. We have the quantity ordered here. We have the order number, which is going to be from the order. And then we have the product ID. So we have 2 foreign keys that are in here. One foreign key, 2 foreign key. So I have 2 foreign keys and an attribute for the quantity. Very similar to the employees who worked on projects relationship table. And then on our product, we have the product ID with the description and other attributes. So this is a nice example of a direct translation, very simplified. So yours is probably going to be a little bit more complicated, a few more entities, a few more stuff that's going to be put in there. So, but essentially the concept is the same, actually. So what about multi-valued attributes? So sometimes we get in a situation where we have an attribute that's multi-valued. This didn't really have any attributes that were multi-valued. This was fairly simple, straightforward. Attributes are descriptions. So in fact, if we had a car and the car had an attribute that was called color, well, that would be multi-valued because we'd have interior color, exterior color, tire color, I don't know, seat upholstery color, all these different kind of colors. There's multiple values that could be associated with color. It's not going to fit in a single valued field. So you make another table for it and you put a link in there. so for each multi-valued attribute, create a new relation, a new table. Primary key is a primary key of the entity type of the multiple valued attribute. So we have department with locations. If the locations were in different areas, then we have department locations with department and location. So D1 is in this country, the D1 is also in this location. And then we can put the department locations in the single valued attribute for the entity that's requesting the multiple values. And we use the linkage between this table to look up the multiple values so we can correlate the right value. So we're basically taking a multiple value and turning it into a single value and keying it to the original table. This you can't tell from the diagram, except the only way you can tell it from a diagram is if you actually put the multiple values in the diagram. The dependency you did yesterday actually had that because you had different types of parts. So you had bolts and nuts and things. So if you just had part, how are you going to know what the part is? Part's a part, right? No, because it'd be nut part, bolt part, nail part, screw part, all these different little parts. So you put them in a separate table and you go part number. And then you know which part number you're talking about. You have one part number and you look it up in the table, what is that part number? It's a bolt, and it's a screw, and then it's a multi-valued linkage with that particular concept. What about n-array relationships in terms of the numbers? So an n-array relationship creates a new entity as well, and then creates a primary key of each entity involved in the relationship to the new entity. So suppliers. So suppliers supply parts from cities. So supplier part city, which means, because it might get it from different cities. So supplier number 1 is part number 1 nuts that comes from this city. Part number 1 also gets nuts from this city. So we can tell which parts are coming from. This is actually going off of your dependency diagram that you're supplying from yesterday's exercise. We can tell from the table, from the n-array. And n-array means that there's any number of parts, cities. Any number of cities can be used to supply the parts, and they're all into the same part, and they're all into the same part number. So whenever you want to keep that level of detail, you create a new table to separate out all of the different options, and then you key it together with whatever number is associated with it. And then at this point, it comes up with a part number again, or something, or a supplier number, and then so you know which supplier numbers are associated with which suppliers, and then which suppliers are making parts in different cities. So this is actually kind of the rare case, actually, and so is this, but it does come up. So whenever you want to do a multi-valued or an n-array type of relationship, it always turns into a separate table. So here's our finished tables. The finished tables look like the original entity relationship diagram, except for this isn't really standard. What I did with this is I kind of mixed the two of them together. So we have entity relationship diagram with table entities mixed into it. So when you see the lines here, we can bring a chair up front. There's a spot up front if he's trying to get into the room. No, we can go get a chair. We have room for one more. We have a spot for you, but we have to get a chair. It's bring your own chair day. You didn't bring a chair? Where's your chair? Bring your own desk, too. No, you'll have to sit on the floor unless you bring a chair. Oh, he's got a chair. Okay, perfect. All right, so sorry about that interruption there. So here we have the employee with the employee first name, social security number. Here's the ESSN here. And the P.K is a nice abbreviation for primary key. I wouldn't draw your tables out like this. I'm going to show you how to draw them out in another example in a few minutes. But don't draw them out like this. This kind of gives you the linkage. So you can study this one as well as the original entity relationship diagram, and you kind of see how the translation finishes and what it looks like in the end. You can also put things like not null and null on things, but it's kind of, unless you know from the business rules from the diagram, you're kind of guessing at that point at the design. So, all right. So let's see the concept actually work. And if we see the concept work, we're going to look at a couple of the uploads that I've done. And what we're going to look at now is this thing called ERD exercise. So if you want to download it onto your computer so that you can actually see it, not a bad idea, because otherwise you have to read it from the screen, and who knows who can see the screen at this point. But if I download it, I've already pre-downloaded it. If I can find it, I might have to download it again. Oh, here it is. It's a PDF file, and it is called a text description of a movie database. So I'm gonna, and you guys can do this as well at the same time, and we'll see how close we are. There's also a solution to this, but don't, and the solution is right next to it, by the way, but don't bring it up yet, because it ruins the learning exercise if you like already know what it's supposed to look like, which is kind of like why I'm not giving it a solution to the data flow diagram until actually you do it, because it will taint your thinking completely in terms of the concept. So what we're going to do is build an entity relationship diagram, take the entity relationship diagram and translate it into a bunch of tables. Not one of the exercises that you have to turn in for the class, but it's a nice exercise for you to go through just to kind of get a feel for how you're supposed to do this. Because you have homework assignments that are going to do this that you'll do after this weekend, that are going to be due before the beginning of the next weekend session, that you're going to want to apply this stuff to. And this is a great way to kind of get your feet wet and while you're here and not have to like struggle on your own. So I'm going to read the description through here, and the description is actually purposely put together to make it easier for you because it's asking a bunch of queries and stuff. So I would like to build a database to store and manipulate information about movies. So we're going to do a movie database. And for each movie, I'd like to know the movie stars that participated in that movie and the studios that produced it. And then once the project is complete, I would like the database system to be able to answer the questions from such queries. And here's some queries. And so your task is to create the entity relationship diagram from a textual description, create the database schema from the entity relationship diagram, and the schema is actually what we just created. So those people who had problems understanding what a user schema was, this is what it is. It's the design that you're creating from the entity relationship diagram. This is one of the questions we had yesterday. So it's the schema. This is an example of the schema, actually. It's a user schema, but it's also a database schema, because who's using this? The user. So you're the designer creating the schema for the user, and then this particular user is going to be answering all these questions like, tell me all the black and white movies that were created, and tell me all this stuff. This is what the user wants to know out of this database. So the schema is going to represent this information. So make a list of the entities, relationships, attributes, and then draw them together. Look at unique values and attributes to form keys for the tables, and then create the tables from the entities. Alright, so I'm going to pull up Notepad. Another person actually, not Notepad, I'm going to pull up Paint, Microsoft Paint. And another student in the class, actually a couple people yesterday were using Microsoft Word and the drawing tools. You can do that, might be easier. I'm just a Paint fan, but a lot of people don't like Paint. So, Smart Draw is also another one, 30-day trial. You can use that one. You don't need it this weekend though, so don't install it yet, because then your 30 days is going to run out before you do the assignment. Or OmniGraffle on a MacBook, or just search Entity Relationship Diagramming Tool, or Visio. I think a couple of people had Visio, but Visio is kind of expensive unless you have a free copy of it or something. I don't know. If you have Visio, that works as well. So I'm going to do it with this little primitive Paint program, however, which isn't too bad, actually. So if I start out with the description, the first thing I'm going to do is put the entities out. Same kind of concept as the dependency diagrams. And I'm probably going to make a couple mistakes as I do this. But we're going to build a database here to store information about movies. Okay, so probably going to call it a movie database in the end. So each movie, you'd like to know the movie stars that participate in that movie, and the studios that produce it. So I'm going to do this with a 3. And I know the solution is going to have it all. I'm going to do it with 3 participating entities. And I know that the solution is going to have it with 2. And he's going to use binary. It's not going to use 2. So I'm going to make slightly different on purpose. I'm going to make a slightly different representation of this than the solution. So you can sort of see the differences. So I'm going to take and create a box here. And another box here, and another box here. And you're going to go, how do you know I'm going to put the boxes here? And if you remember yesterday when I was starting to show you the patterns on the entity relationship diagrams, we have binary, which looks like 1 to 1, and we put a line in between. And then we have 3 to go together. And then we have this pattern here. Oops. 1, 2, 3, 4, where we have 4 of them together. We don't go past 4. And we put a diamond symbol in the middle of it. I already know this is going to be a 3 from the first sentence, if I take it this way. I'd like to know the movie stars that participated in that movie and the studios that produced it. So if a movie star that starred in a movie and a studio that produced the movie, there's 3 people. There's 3 components. So as a cheat sheet, I know I'm going to have 3 of them, so I'm going to clean this up a little bit over here. And I'm going to use this combination here. So I know one of them is going to be movies, and the other one's going to be stars, and the other one's going to be studios. And stop me as we go through this, because I'm just going to assume that you guys are following along. If not, I might be going too fast. So movies, stars, studios. And then I can possibly draw a diamond. See, let's see how the diamond's going to work, actually. The diamond's going to work, okay. And then I'm going to use the word produces in here. So my diamond doesn't look that good. Your diagrams can look like this too. Doesn't really matter. It's not a beauty contest in terms of art. So then I'm going to draw the lines. That looks pretty good. Not bad for paint. So let's see. So we have movie star. So I've accomplished sort of the descriptive part already because I knew that information. And then I can start looking at this stuff down here for the attributes and things that are going to be associated with each one of them. In the problems that you're going to get, this is going to be a little bit longer. Because this one's going to be, this is like a one-sentence description just to illustrate the concept. You're going to get other stuff that says, and stars have this, and movies have that, and movies are produced by manufacturers. And then what ends up happening is you start extending it. So like, and studios have, and then you put something on here. You know, and stars have that. So what you're doing is kind of starting with a base and then you're adding functionality to the base in the most part. But we're going to just start with this base here. We could draw it out, and I'm going to draw it out here just to do it one more time for you to illustrate another point. I'll make the boxes a little bit smaller. We have movies, stars, and then the stars, the movies are produced at studios. So I could do this. Go copy, paste. Movies have stars. And movies are produced at studios. So I can go down here and go, oops, I didn't want to do that. Copy, paste, stars. Copy. I think the TA might need to get you another chair. I don't know if there's a chair up here. Is there a chair? Oh, there's a chair? Oh, okay. Sorry about the accommodations. You guys could send in a complaint to ITU. Tell them that you were squished into a little room. It might help us expedite the new accommodations. Especially if I'm the only one complaining about it. They don't listen to me. So, alright, so what we're looking at here, just to regroup it back again. Hello. I've got this other one over here I kind of just put together a few minutes ago where I've got movies that have stars and movies that are produced at studios. And I can actually put two different relationships on here. And I didn't use the diamond symbol because I have a one-to-one, if you remember that. But I can put something on the line and I can say movies have stars. And I can put halves up here. And then movies are produced at studios. So I could use the word produced over here. Oops, I don't want that. Let's undo that. Produced. And then I could quickly see how, okay, well, I could go like that with it, you know. So it doesn't really matter. The way you're doing your diagrams, it can be anything. What I'm looking for is the concept. So I basically have two kind of starter diagrams that are representing the same concept. But one of them has one relationship and the other one has two relationships in it. Because we have one relationship between movies and stars and one relationship between movies and studios. So 1, 2. But this is really one relationship. So when I start translating it down, I'm going to have two separate relationships that I'm going to have to consolidate. Because I don't know. If I didn't think about this part of it, then I'd have to consolidate, and we're going to go through the little consolidation, and you'll see how that works in a few minutes. But let's finish with the description. So once the project is completed, I would like the database system to be able to answer the queries such as, well, that's not really part of the diagram description. That's just, you know, some information about the database that I'm building. So tell me all the black and white movies which were made between 1930 and 1950. So movies over here, I'm going to need to know, and what I'm going to do is kind of draw this in a box actually, and move it around. So I need to know black and white. So this is going to be what color, maybe, and then year, perhaps. So year, maybe. So if I wanted to, I could do this with it. I can go movies and then draw a box here. This is where the tools kind of come in handy because it'll automate this for you. And then put some attributes in here. And the attribute might be, whoops, not that one. Attribute might be color and year for the movie. So I can query this table. This table is going to give me the color of the movie plus the year between 1930 and 1950. Okay, so then the next one here, tell me the movie names produced by Studio Fox that feature Tom Cruise. So movie names produced by studios. So in here we have the studios. So we're going to get that from a query. We haven't looked at querying yet, but some people already have sort of a background in the concept of querying from an undergraduate course that they've taken in databases probably to figure out that, well, that's going to come out of a query with two tables. And so where would I logically put the data? Well, if I were to look at this, I need to have the studio names, right? And I need to know the star names. So I can do this. It's just, I probably should have done this originally, but and this is just one style. The solution is going to have the little bubbles on it. So I'm going to want to know, tell me the movie names. So movie names, and which we're going to have to add something to movies now, and produced by studio name and actor name. So name. So star name. So let's see, studio name, star name, and actor name. So studio, stud name. Oh man, let's see. Studio name, star name, and movie name. I just put here name. So then I'm going to add the attributes in. And then I'm going to go to the second one. And it's going to say, which female stars participated in more than 3 movies? Female stars, so now I got a gender. So I'm going to put gender in here. Gender. So stick gender, put it up here in the stars. And then, let's see. Because that's going to be a query out of one table. And then we have what studios produce movies featuring Nicole Kidman? So that's going to be an actor and a studio. So which studio produces movies with control? Well, we already have that. Yeah, so we have the star name. So we don't have to put anything in for that, actually. So that's pretty good. And what movie has the longest duration? Well, that's a no-brainer. We put the length. So here's the movie, and now we add length. Length. There we go. And then I realized, oh, I need to make this box a little bit bigger if I wanted to clean it up. I'm not going to. I'm just going to leave it like this. So now, with this very short description, I've built this entity relationship diagram right here. It's complete. This is another variation. I could have added the same information with the attributes, and I could have used bubbles if I wanted to connect it together. And then I've only included the attributes that were in the description, which means I didn't think for the customer. I just say, well, you know, what about locations of the studios? And what about this? And what about that? You know, I didn't think ahead. What the customer doesn't want is to see, especially if you're doing this for somebody, you're designing, and they've given you this description, and this description came from an email message or something. Hey, can you build me a database that creates movies and extracts all this information? You don't want to think ahead, because if you start thinking ahead, then they're going to think, oh, this is not my database. And then later what you do is you take this and you go over to them and say, you know, this is a nice diagram nice information, but you're missing this, and you're missing that, and I don't know about this. And this business rule is not stated correctly. So one of your assignments is going to have you do that, actually. State assumptions that you have to make. And this is how you get the assumptions. So if you look at this and you go, well, there's nothing about this, and you're assuming you're talking about gender, but how do we know what, you know, yeah, we don't even have this information. What about the address of the stars and all this other stuff? So those would be assumptions that you're making about information that the customer would want to put into the database. Also, you have inconsistencies where they say something and then they contradict it with another statement that says, well, and we want it to do that. Oh no, but it doesn't need to do this. Well, if it doesn't need to do this, how is it going to do that, kind of thing. So those would be inconsistencies and decisions that you'd have to make above and beyond what was going on in the diagram. So now this next step here is to translate it into a bunch of tables. So what I didn't do here is identify possible primary keys. So I've saved it because the customer didn't talk about movie names, or we talked about movie name, but it didn't talk about movie IDs or anything. The customer didn't tell me about star names or anything, or studio names or anything. But I do have information that I can use in here. So the first thing you want to do is try to use the information that's available in the attributes. So what I'm going to do here is starting with the methodology that I showed you a few minutes ago. And the methodology says we'll start with all of the entities. Take all of the entities and turn them into tables. So I said, all right, so this is how I'm going to draw it, actually. I'm going to start with movie, and then I'm going to put in this open bracket here. You don't have to put in an open bracket. You can use a curly bracket. You can use a set, because it's really a set that you're creating. So I have the name, I have movie, and so I'm going to look at the movie list and go, well, okay, so we have name, could possibly be a key. What do we got? Year. Okay, we have length, color, and then anything else that we might have in there. I put a little dot in there because I might go back, change it. Who knows? And then I have stars, and then I'm going to do the same thing. I'm going to go, well, I'm going to have star name. And then I have gender. Actually, up here, I'm going to take this out because I don't really need that in there. And then I have studios, and then studio name. And then I have, oh, I don't have anything left. I'm done with all my attributes. I'm done with all my entities. So then I take all my relationships and I put them out. And this one only has one. It's called produces. And in the produces relationship, I have a studio name. I have all of the primary keys, and I go, well, what are these primary keys? Well, then I have to come back up here and say, well, I've got name. And so before I haven't finished, which is the problem. So I've run into the situation where I have to start populating this relationship, but I haven't finished because I haven't identified my primary keys. So I could go back at this point. This is what I'm going to do. I'm going to go, okay, I'm going to call this one a name. And I probably should have called it movie name or something. And then this one's going to be studio name, and then, or star name, excuse me, and then studio name here. So then in here, I could start out and say, well, okay, produces. And then I'm going to say, okay, name, which is really the movie name, star name, and then studio name. And I'm going to be, well, that's it. Actually, that's my relationship, actually, that's going on there. Whoops. Yeah. Hold on a second. Let me make this look a little bit better. There we go. Put it right here. And then now I've realized name, that doesn't make any sense. So then I can come back and I can go, that probably should have been movie name. I'm not going to correct it, but I did that on purpose to kind of tell you that this is kind of the naming convention. You want to be able to, when you look at this produces, you want to, what in the world is name? Well, I know star name is studio name, but I don't know name. Well, that's movie name. Okay, well, all right. So I know what's in here. And then I got 1, 2, 3, 4 tables that came out of this. And believe it or not, this is done, actually. So let me take a look at the solution and show you I'll leave this up for a second because I'm going to compare the solution with what we did, and you're going to see a slightly different variation of this.
We can add one more thing to movies. We can add a category. It's a foreign movie or.
Well, you can add a lot of stuff to that. Do you want to, though? If you did that, here, are you going to take a picture of that? Hold on, I'll make it a little bit bigger. There we go. New technology. People take pictures of screenshots. I'm also recording this, by the way, as well. So you can take a snapshot of the video. Hopefully we'll have sound today as well. I had an issue with sound yesterday. So here's the other one I kind of put together, but when I put it together, I drew it down this way instead of putting it this way. So I made if you remember that variation that I did with 2 relationships instead of 1, but I like to do squares. I'm like a square person. I don't know. I like to do lines and stuff. And I didn't put the diamonds in here, but I put stars in and produces. So I gave you this one, but I didn't complete it because this one has a problem to it, actually. It's not a problem. It's just more work. The more entities you can group together in the same relationship, the easier the translation is. Remember how easy that was a few minutes ago? Because we only had 1 relationship. With the 2, if we follow the methodology correctly, we convert each one of the entity sets into a relation, and then we use the attributes of the entity sets as attributes of the relation. And I think I left out the foreign keys as well, but we can add the foreign keys back in as well. But so we also convert each one of the relationships into a relation, as many attributes as the keys are connecting them together. And then for each one of the many-to-manys, the stars and the union of both of the keys, we can put them together. So we ended up with 1, 2, 3, 4, 5 tables. On this first iteration, we ended up with 5 tables because we have 1, 2, 3, 4, 5 items. Yeah?
How can a year could be a key?
How could year be a key?
Yeah.
Where is year?
Movies.
Underline the year, right?
It doesn't really have to be. In fact, the table, it's not set in stone. When you do this and you start underlining stuff, it's common to underline the wrong one. You don't have to put a year. I should probably modify this to take that out because it is kind of confusing. Because year doesn't turn in year here. You got a second key in here. It's kind of, you don't necessarily need the year in there. If you put, okay, so the reason why the year is in there is because this is following a slightly different, well, not slightly, it's an add-on feature. Okay, so anything you make a key ends up getting indexed. And one of the things that said I wanted to query on was the year that the movies were produced. So if you queried on the year and you know you're going to run that query a lot and you index it by making it a key, then the query runs faster. But you can run the same query without it being a key. It's just going to run a little bit slower. That's why it's actually underlined as a key. But it doesn't have to be, actually. There's nothing tying it together. What we didn't do is identify, movie name instead of title. That was okay. So going back to the original thought here, if I got 1, 2, 3, 4, 5, then I'm going to have 5 resulting tables. So if you did 5 relationships, you should have 5 resulting tables. Excuse me, 2 relationships. If you did 1 relationship, you're going to have 4 tables that come out of that. 3 entities in 1 relationship.
And isn't that when you put year together with title, maybe the title of the movie is like same movie, different years had come up.
Yeah.
So then it become with the year.
It would give you the ability to search on it by year instead of by name, to give you that combination. Yeah. No, that's another. She made an excellent point. But you know, now they're movie names though are, you know, it's like Ghostbusters 1, Ghostbusters 2, Ghostbusters 3, instead of just Ghostbusters in 1999, Ghostbusters in year 2000. You know. I'm more along the lines of changing the movie name, putting in movie number 1, movie number 2, movie number 3 instead, and then, but you could, the originally design of this table was to have it by year, to be searchable by year, so, which is why that's a key in there. But this kind of violates also the concept of there only being 1 primary key, which there should only be 1 primary key in a table. There's no such thing as a secondary key. In Oracle, at least. So, but that would be a secondary key. So instead of underlining, the keys are actually bolded. So we have here a bolded title and a year. So we have movies, stars. Okay, so where'd this address come from? And the birth date come from? Well, that's kind of an interesting thing. So people added stuff. You could add attributes in if you think it's going to be logical. Like so as an example, do we just want to know the star name? In fact, out here, I believe we just had the star name and gender. So we have to put the gender in here, but what about the address and the birth date? So we added some information to that. You can add some logical stuff. Don't go too extensive on it, because if you go too extensive, the customer's going to go, whose database is this? You know. For the studios, the name. Okay, so the address was put in here as well. So on the studio name is what we have in here. So they're both sort of correct. There's no right or wrong answers in terms of the extra stuff you're putting in. So here are two relationships, which is kind of interesting. We have the stars in and then the produces. So we have the movie title, movie year. We used the movie year here because we have a year up here. We could have used movie title as well if we didn't put in year, which is what I did. So your choice, and this is I did this sort of on purpose just to sort of give you an illustration. Your choice on the keys is up to you. Some people actually like to put numbers in there, like studio ID, movie ID. If you do that, then you're going to make those your keys instead of the movie name, and then you're going to have, you know, a different kind of key system. But you're still going to have a key system, bottom line. So here we have the two relationships, the stars and then the produces. And what we end up just doing is we start looking at this, and then here's the second step. If you're doing it with multiple relationships rather than combining all the entities, if you take the route of just doing multiples, we have to eliminate one of these tables. And we have to go through step number 2, essentially, that's going to essentially go, where do we have all this duplicate information? So we can simplify the model, because now we have two relationships instead of one, by eliminating the relation corresponding to the many-to-one relationship in the produces by adding the attribute studio name to the movies relation. So we can condense these two down and keep one of them. If we don't condense it down, we end up with duplicate information. So if we put the two relationships in instead of the one, if you're always doing binary, if you're always going like this, you're going to have reductions because you're going to have duplicate relationships. If you group them together, then you don't have to do any reduction. However, this is harder to think about it grouped together. Most students find it more difficult to think this way, and they naturally want to go this way. So it depends on where you want the more work. Do you want more work with the diagram, or do you want more work with the translation of the diagrams? And some people prefer this method with translation, because you can easily look at these two and go, well, what's different? We have movie title, movie year, star name, movie studio name. Can we just condense them? And then we end up with movie title, movie year, star name, and stars in. And we get rid of this other one that we don't need anymore because we can get the information elsewhere. So then we have to think ahead to querying in order to make that possible. So that is the solution. In both the exercise and the solution is posted out here, and this is what is on the day 2, exercise and solution. This will help you with the assignments for the course. So let me show you about the assignments for the course, because this is a good transition to go into that. If you click on the course materials link, you'll see all of the lectures. The one that is related to entity relationship diagram, by the way, is 4A and 4B. You have 5 different assignments, 3 of which are due at the beginning of the next weekend, and I'll repeat this on Sunday as well. But the first assignment, let's see if I can get this opened correctly. Is on entity relationship modeling. So we're not going to build any more entity relationship diagrams in class. Instead, you're going to use that as an example, as a technique to apply towards different, and this is 23 pages long, by the way. So this particular assignment is a book as well. You'll read through the descriptions, and it'll show you this, and it'll show you that, and it'll show you all the nitty-gritty details about how to create entity relationship diagrams. Shows you the different relationship patterns as well, recursive patterns, and participating entities, all the different variations of how to put the diagrams together. And then at the very end of the assignment, if you get there that far, if you can make it down to the very end of the assignment, there are, can we keep the volume down a little bit? Hello. We're going to take a break soon, but I don't want to yell, and I know people can't hear me when it's distracting to everybody. So we'll just be courteous. Okay, so if you get down to the end of the assignment description, here's the assignment here. Assignment, complete 4 parts of, as described below. Part number 1 is an exercise on cars. Example number 2 is on a university system. Number 3 is on a mortgage system. Very similar to what we just did. You're going to be reading a description of a problem. And in the problem description, I'll look at cars for a second here. And I'm going to make this a little bit bigger so I can see it actually, because I'm having problems seeing it as well. Let's see. How do I get rid of the side piece? Okay. I'm sure there's a button for it. That's big enough type, but I have to scroll back down to the cars. Okay, here's our cars. Identify all entities, attributes, and relationship types and their degrees in the following case. Hence, draw an entity relationship diagram. The assignment description I'm reading to you right here. On exercise number 1, an organization makes many cars, which of our models are characterized by a name and a suffix. So we know we have cars is going to be an entity. It's going to have a name, a suffix associated with it. Indicates the degree of luxury and engine size. Each model is made up of many parts, very similar to the dependency diagram that you did already, which is why we did that dependency diagram. Hopefully it's going to help you with this first one. And so many different parts. Parts are used in the manufacture of the model. Slight variation though. Each part has a description and an ID code. Those are going to be attributes. Each model of the car is produced at just one of the firm's factories. Oh, we have factories. So we're going to have another one. Another entity called factories, which is located in, and these are locations for the factories, which is going to be an attribute. Hopefully you'll figure that out as terms of location. So some of the descriptions are giving you instances of these particular items, which is the case here. These are not separate. I've had people draw this up with factory number 1, factory number 2, factory number 3, factory number 4. And there's a lot of duplicated items on this. So condense it all down, put them into separate entities, and then draw a diagram for it. The first one is straightforward, easy to do, actually. The next one, I'm not going to read through it, but the important part is at the end here. Draw an entity relationship diagram that models the example, both cardinalities and optionality. So the first one is just a basic diagram, doesn't require anything. The second exercise is going to have you put in the optionality and the cardinality. Talked about that yesterday. It's also in this assignment description. Put a question mark where the degree is not clear from the text. So you're going to have situations in which you can't build the diagram because you don't know, you can't put it in. It's going to be a question mark. Don't assume anything, rather write a list of questions you would have to find answers to in order to complete the model. And as an example here, and I'll just read you a couple of sentences here, which will demonstrate the point. University consists of several faculties. Faculties, okay? Within each faculty, there are several departments. So most people go, faculty. Don't assume that this is written correctly. So don't assume that this is going to make sense. Each department may run a number of courses. All teaching staff is attached to a department. Each staff member belongs to a unique department. See how many different meanings can be assigned to this ambiguous sentence. So you're given words that don't make sense. It's not your reading comprehension. It's the fact that the description isn't making any sense. Because customers are going to come to you and say, hey, I need to keep track of faculties. Each faculty is located at 5 different locations, and then there's classes with subclasses and subcourses. And you're like, well, what are the subcourses? What are these things? So then you have to write a list of questions. What's a faculty? What's a subcourse? And then complete as much as you can, and then put question marks in for optionality and participation. Third one is very similar as well, but not quite as ambiguous. The fourth one has got interesting problems in itself. So you'll discover the problems in all cases except for the first, you'll be able to create the first one. The next ones, you're not going to be able to create the whole diagram. It's going to be parts of it that you'll put together, and then parts of it you'll have to kind of, mimic, sort of. So, all right. So that is the first assignment that you're going to have to be able, that you're going to be doing. The second assignment is not so bad. The second assignment is just like the first one, except for now you're taking those tables, and it's just one. You're going to convert it into the entity relationship diagram. So this is number 2. You're going to take and create a diagram, one diagram of a university registration system, or a university system actually. Drawing the diagram and then converting the entity relationship diagram into a set of tables. So this is like the exercise that we did a few minutes ago with the movie database. Very similar to movie database. The third assignment, I believe, let me just look at it real quick here. The third assignment is on SQL queries. So I'm going to wait with that one, because after lunch today we're going to look at SQL queries. So what we're going to do now is take a small break, because some of you have been sitting here for a while and have to go to the bathroom or something. So we will reconvene in, say it's 10:44. Actually, let me stop this video.